Okay, so John asked a very cool question, which is really, can I use shifting rules to graph some quadratic that's not in kind of standard form, right? So what I should think is, well, I would like to use the techniques I've just been using, right? But to do that, I need to somehow think about this thing as some stuff squared plus maybe a number.
Yeah.
Holy shit, I actually have a technique for doing that. You remember what it is?
You can factor that out, right?
Yeah, factoring won't help you.
Okay.
Well, factoring would help you, but not with shifting rules.
Completing the square?
Yeah, this is complete the square.
Okay.
So if we thought about this as, okay, so to complete the square, I need a coefficient of 1, right? Okay, so let me rewrite f by factoring a 2 out. So I've got x squared plus 4x plus 1. I factor a 2 out?
8.
8. Okay, and then I might think to myself, okay, can I complete this square on that? So I need to complete the square in here, which is a little bit different than the complete the square we did.
Okay.
So I'll have my x squared plus 4x, then I need a blank, then there'll be a plus 8. Oops, I can't really add a blank, right? So yeah, I'll need to subtract it to get rid of that thing, right? You guys see that? But otherwise, this is the same complete the square technique we already used. So to get this into a x plus something squared form, what do I need? What's the complete the square technique? How do I get from the 4 to that number? Yeah, I multiply by a half, divide by 2. So I get a 2 in here. Then how did I get to the blanks and complete the square?
Square it.
Yeah, it's square. So what's 2 squared?
4.
4 in both of these. Right? So then all of this stuff, right, that's in there.
Okay.
And these two aren't. So I've got a plus 4 left over. And then I can distribute my multiply by 2.
For the
So I can find out that f of x is twice x plus 2 squared plus 8.
okay.
Okay, now I can think about this as a function diagram. So I might think, okay, what's happening when I put an x in here? So first things first, what do I do?
Add 2.
Okay, we add 2, then we'll square, right? Then the next thing is multiply by 2. Then the next thing is add 8, and then we're done, right? So if I'm thinking about these in shifting rules, right? This one is, wait, not up, I screwed up. What is it?
Horizontal.
Yeah, this one's happening before the rule I know, right? There's my kind of, that's the rule I know about. So this is a left 2, right? Left 2 shift. Okay, then there's a multiply by 2, which is a
Vertical stretch.
vertical stretch, which will amount to a narrowing of mine. So vertical stretch, multiply by 2, right? Then this guy is up by 8.
vertical stretch is like if you had the points 1, 1, or just turn into 1, 2, right?
Yeah, exactly. You multiply the y coordinates by 2. So my parabola to start with looks like this, right? It goes through 1, 1, minus 1, 1, and 0, 0. Then I move it left 2, right? So now it'll go through
-2, 0.
okay, so my vertex will be at -2, 0. And then my other 2 points that I'm keeping track of will be at
-3, 0, and -1, 0.
-3,
0.
1,
right.
because I'm shifting horizontally, right? And -3, oops, not -3. -1, 1. So there's my parabola again. Okay, so that was the left 2. Then there's a vertical stretch by a factor of 2. So that'll make everything narrower. Oops, wrong color. So it'll still go through -2, 0, right? Oops. And then so it'll still go through -2, 0. And now my other 2 points are at,
-3, 2.
yeah, exactly. So they're shifted, or stretched up by a factor of 2. So I've got -3, 2, and -1, 2. So my parabola is now narrower. And then what's the last thing?
Okay.
Shift the whole thing up 8 units. Right? So on my picture, really that amounts to move everything over and just move the x-axis down, right? So where are my 3 points now?
-3, 10, and -1, 10, and -2, 8.
Oops, that one's, sorry. This one's -3, 10. Yep, oops. Writing is hard today. Okay, -3, 10. This one is at
-2, 8.
-2, 8. And this last guy is at
-1, 10.
-1. You guys cool with it? So this is another thing complete the square is good for. It's good for a number of these kind of look at this thing in a slightly different way. Specifically, equations of circles are another good use for complete the square. Questions on this? Okay. Awesome question.